Hey guys, welcome to the lab on reflexes. It's the last lab of the nervous system that we're doing. And bad news is this might be the shortest lab video of the whole semester. So a reflex is basically a rapid, automatic, predictable response to a stimulus. Okay? So we're going to give a bunch of examples of reflexes today. If you got poked in the skin with a pin, you would probably pull that body part away. That would be a reflex. That would be an example of the withdrawal reflex. And that's what we're looking at here. We have the components of what's called the reflex arc, which is the series of things that come together to allow a reflex to occur. And notice if I look at all the stuff, it kind of has a curvy arc-like shape. So first of all, you need a stimulus, and you need something to respond to the stimulus. The thing that responds, that detects the stimulus, is a receptor. And then we got a sensory neuron, basically an afferent pathway, towards an integration center, which in this case is this neuron called an interneuron, because it's in between the sensory and motor neuron. And we got our motor neuron, which is our efferent path, and we got our effector. We've seen this before. This is the basic homeostatic feedback pathway that we've dealt with already. Now, those are the basic components of my reflex arc. Receptor, sensory neuron, integration center, motor neuron, effector. RSIME, RSIME, however you want to remember it. Those are your 5 basic components. By the way, make sure you can identify everything in the spinal cord here. You got your anterior median fissure, your posterior median sulcus, dorsal horn, lateral horn, ventral horn, anterior, lateral, posterior columns, gray commissure, central canal. Make sure you know all that, okay? All right. Get out of here. Let's keep on going. So we got the basic idea of a reflex, hopefully. And now what we're going to do is have some actual examples of reflexes, things we might test, things we might name. Okay? This is a common reflex. This is a reflex that's tested all the time in a doctor's office. It gives you a quick, good assessment of spinal cord health. It's easy to do. This is a stretch reflex. So if we take a reflex hammer and we hit the patellar ligament of someone sitting down, their legs nice and comfortable and dangling. If we hit that patellar ligament, it creates a slight stretch. So we know patellar ligaments attached to the patella, quadriceps tendon, and then the quadriceps femoris muscle. And what happens is we get a stretch in that muscle. And one of the things your bodies do is when you stretch a muscle, you respond by contracting it. This is one of the ways we maintain posture and balance, actually. So when that muscle is stretched, a receptor, it's called a muscle spindle, is going to detect that stretch, give the information to a sensory neuron. We see a beautiful unipolar sensory neuron here, coming in through dorsal root ganglion, dorsal root, into the dorsal horn. Now, in this case, the sensory neuron synapses directly on the motor neuron. Then the motor neuron goes out the ventral root, stimulates the quadriceps muscle, quadriceps contract, and the leg kicks. The knee extends a little bit. We got all 5 components. There's a receptor, there's a sensory neuron. The integration center is actually the synapse right here. And then the motor neuron and the effector. Now, this reflex can be classified in a bunch of different ways. First of all, this is considered a monosynaptic reflex. How many synapses do we have in our integration area? 1. One integration synapse. There's no interneuron present here. So 1 integration synapse makes this a monosynaptic reflex. All right, that's one way we can classify it. This is also an ipsilateral reflex. Ipsilateral means on the same side. Okay? The stimulus and the response are on the same side. You hit your right patellar ligament, your right knee is going to extend. Ipsilateral reflex. Now, this is also a spinal reflex because our integration center was located in the spinal cord. What else? This is a somatic reflex. Our effector was a skeletal muscle. We had a somatic motor neuron leading to it. If your effector is a skeletal muscle, it is a somatic reflex. All right. That's pretty much it. Let's go on and do another reflex. All right. Touch a candle flame. You're going to pull back. That pulling back, that withdrawing is what gives this reflex its name, the withdrawal reflex. If you touch the candle, your biceps brachii muscle is going to contract, hand's going to withdraw. We have all the reflex arc components here as well. Receptor for the change in temperature, sensory neuron, nice unipolar neuron, going into our spinal cord. Now we have an interneuron, which is our integration center. So we've got two synapses for our integration center here because we have an interneuron. Then a motor neuron out to our skeletal muscle, the biceps brachii, which is an effector. So we still had skeletal muscle, so this was still a somatic reflex. Our integration center was still the spinal cord, so this is a spinal reflex. It was a same side event, stimulated the right finger, response happened in the right arm, so it's ipsilateral. One difference, though, between this and the stretch reflex that we just looked at is that this is a polysynaptic reflex. I have 2 synapses within my integration area. So more than one is many. Poly means many. This is a polysynaptic reflex. Okay, so we got 2 examples of reflexes so far. We've got stretch reflex, which is a great example is the patellar reflex that we discussed. And then we have withdrawal reflex. We're going to look at 2 separate reflexes here. It's getting a little more complicated here, but that's okay. So we got a guy, he's walking around wearing some shorts, and he steps on a tack. Painful stimulus, right? There's going to be a receptor for that. Sensory neuron goes up. Sensory neuron goes up, 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 up. Nice unipolar sensory neuron into the dorsal horn. And then got an interneuron with a bunch of branches here, okay? Going to a motor neuron, which is going to stimulate flexor muscles to bend that knee and get that foot off that tack. So that's the withdrawal reflex. We have the withdrawal reflex here. Step on a tack with your right foot withdrawals. Receptor, sensory neuron, interneuron, motor neuron, and that hamstring muscle back there is going to be our effector. So we got the withdrawal reflex. Classic, just like the last time. It's polysynaptic because I got an interneuron. It's ipsilateral because it's on the same side. It's spinal because my integration center is the spinal cord. And it's somatic because my effector is a skeletal muscle. But there's another reflex going on. This starting at the same receptor, same sensory neuron, but now our interneuron has a branch here that's going to synapse with a neuron that's going to go across, and it also goes across itself. So we are crossing the gray commissure and synapsing a motor neuron on the opposite side, which is then synapsing with a skeletal muscle on the opposite side to make this leg stand straight so you don't fall down. So we're extending our knee on the opposite side. This is called the crossed extensor reflex. Okay? So when we step on a tack with our right foot, our left leg is going to extend to maintain our balance. That's the crossed extensor reflex. It's somatic because the muscles being used on my left leg are skeletal muscles. Integration is still in the spinal cord, so it's still spinal. But now it's contralateral because our stimulus was on the right leg, but our response was on the left. And we can see in a contralateral reflex, our interneuron has to switch sides. We have an interneuron which makes this reflex polysynaptic as well. All right, so now we've got a third reflex we've added. We did stretch reflex, withdrawal reflex, and the crossed extensor reflex. Got one more reflex to do. Here we're looking at the neuronal pathway of the pupillary reflex. You can do this at home. Find a volunteer, shine a light into their eye, and see the reflexive constriction of the pupil of that eye. We're going to have all the arc components as well. There are photoreceptors in your retina that respond to light. There are going to be sensory neurons that are going to go back towards your brain. Your brain is going to have interneurons that are acting as the integration center. And then we're going to have motor neurons going out to the pupillary sphincter muscle of the eye. So, this is an autonomic reflex because the muscle in the pupil is not a somatic muscle. It's not a skeletal muscle. It's a smooth muscle. You don't control it. It is under the control of autonomic nerves in your autonomic nervous system. So that makes this an autonomic reflex. It's a cranial reflex because our integration is happening in our brain. Now, when you shine a light into your right eye constricts. That's an ipsilateral reflex. By the way, there's a separate reflex going on. If you shine a light into the right eye, the left eye will constrict. And that one is a contralateral reflex. Lastly, because we have interneurons in this reflex arc, this is a polysynaptic reflex. So this is our final reflex example. We did the stretch reflex, we did the withdrawal reflex, we did the crossed extensor, and now the pupillary reflex. You should be able to classify all of these reflexes. You should be able to know all the components of the reflex arc and what they do. And with that, this short, super quick lab on reflexes is done. Shortest one of the semester, guys. Bye-bye.